using partial derivative आपण याचं काय करणार आहे एरर फाइंड आउट करणार हे आपण मेजरमेंट घेत असतो बरोबर लेंथ मेजर करतो स्केल ने लेंथ मेजर करत असतो बरोबर ना तर एखादे रेक्टँगल आपल्याला दिले बरोबर त्याची जी लेंथ आहे a डिनोट केला त्याची ब्रेथ आहे त्याला b ने डिनोट केला आपण बरोबर एरिया ऑफ रेक्टँगल आपल्याला माहिती आहे कसा फाइंड आउट करायचा एरिया इज इक्वल टू a into b बरोबर जर तुम्ही त्याची लेंथ मेजर करताय किंवा ब्रेथ मेजर करताय तर त्यावेळेस तुमचं मेजरमेंट करताना तुमच्याकडून चुकीने ती लेंथ चुकीची मेजर झाली सपोज ही लेंथ जर असेल 15 सेंटीमीटर बरोबर तुमच्याकडून चुकून ती लेंथ किंवा स्केलमध्ये काही एरर असेल त्याच्यानुसार ते 15 पॉईंट किंवा तुमची 14.9 अशी मेजर झालेली आहे किंवा जास्त येऊ शकते 15.1 तर हा काय झाला जर 14.9 जर येत असेल तर ॲक्च्युली ते तुम्हाला किती घ्यायची स्केल 15 सेंटीमीटर म्हणजे काय झाला -0.1 हे काय त्याच्या लेंथमध्ये येतं बरोबर किंवा जर 15.1 येत असेल तर 0.1 काय आहे त्याच्यामध्ये एरर आहे तसंच बी त्याची ब्रेथ मेजर करताना तिथे पण जो काही मेजरमेंट आहे सपोज जी ब्रेथ तुम्हाला पाहिजे की 10 सेंटीमीटर पाहिजे तुम्ही जर घेताना जास्त झाले तुमच्याकडून 10.001 एवढे एरर जी असणार आहे ती स्मॉल असणार आहे मिस्टेक म्हणजे काय तुम्ही जास्त 4-5 सेंटीमीटरची मिस्टेक नाही करणार आहे बरोबर आहे ना त्यावेळेस मेजरमेंट पण नसते जी नॉर्मल 0.01 0.001 अशी काहीतरी एरर त्याच्यामध्ये असणार सो तर एरर जर सपोज त्याच्या लेंथमध्ये एरर झाला किंवा त्याच्या ब्रेथमध्ये एरर जर झाला तर त्याचा इफेक्ट कुठं होणार आहे एरियामध्ये होणार आहे त्याच्या एरियामध्ये बरोबर ए मध्ये झालेला एरर बी मध्ये झालेला एरर त्याला करस्पॉन्डिंग जो एरियामध्ये एरर जो येणार आहे तो आपल्याला कसा फाइंड आउट करायचा ते आपण पार्शियल डेरिव्हेटिव्हचा यूज करून तो एरर काय करणार आहे फाइंड आउट करणार So you know that if we consider z is a function of x and y, right? And the function that is explicit form मध्ये आणि आपण फंक्शन बघितलेले f म्हणजे तुम्हाला आपण पार्शियल डेरिव्हेटिव्ह मध्ये बघितलं होतं explicit फॉर्म मध्ये फंक्शन दिले f of x y is equal to 0 or f of x y is equal to some constant c जर असेल and y is a function of x y is an explicit function of x असं जर असेल तर dy by dx ह्या डेरिव्हेटिव्हची जी व्हॅल्यू आहे डेरिव्हेटिव्ह y with respect to x if f of xy is equal to 0 and y is a function of x तर dy by dx तुमचा येणार आहे minus by y x या डेरिव्हेटिव्हची व्हॅल्यू राइट हे जर आपण क्रॉस मल्टिप्लिकेशन केलं याला सिम्प्लिफाय केलं या टर्म्सला तर आपल्याला काय मिळेल बघा y इथे डिवाइड आहे त्याला जर तुम्ही LHS ला शिफ्ट केलं तर तो मल्टिप्लाय होणार आहे बरोबर दॅट इज y dy is equal to minus x that is minus जी टर्म्स आहे x dx ला तुम्ही LHS ला जर शिफ्ट केलं x dx plus y is equal to 0 असल्यामुळे आपण तिथे 0 राईट डाउन केलेला आहे सपोज व्हेरिएबल जर z असेल f of x y is equal to z बरोबर z तर इथे आपण घेताना तो टोटल डेरिव्हेटिव्ह dz असेल So in case if z is equal to f of xy, then the total derivative of z of the function f of xy is by x dx plus by y dy. अजून त्याला तुम्ही सोपा करायचं झालं तर त्याला तुम्ही असे शिफ्ट करून म्हणजे पूर्ण फंक्शन f of x y z चे जर घेतलं इज इक्वल टू 0 म्हणजे काय by x dx plus by y dy plus delta x by delta z dz is equal to the right. मग याच्यामध्ये जे dz dx dy याचे रिप्रेझेंट करणार आहे dx dy dz represent actual error काय रिप्रेझेंट करणार आहे एरर रिप्रेझेंट करणार ऍक्च्युअल एरर सो तुम्हाला सांगितलं आपण जे रेक्टँगल ड्रॉ केला होता त्याच्यामध्ये 0.1 जो काही एरर आलेला आपण कशाने रिप्रेझेंट करणार dx जर लेंथला आपण a ने डिनोट केलं बरोबर ना मग a मध्ये जर एरर असेल तर तो जो एरर 0.1 आला होता बरोबर ना तो कशाने रिप्रेझेंट करणार आपण dA जो काही पॅरामीटर असेल त्याचा डेरिव्हेटिव्ह म्हणजे dA असा आपण रिप्रेझेंट करतो सो वी रिप्रेझेंट dx dy dz represent actual error in the variable x y and z respectively dx upon x dy upon y dz upon z represent relative error. This is called as a relative error in variable x, y respectively. 100 dx upon y x, 100 dy upon y, 100 dz upon z represent percentage error in the variable x, y, z respectively. The notation महत्वाची actual error कशाने represent करणार relative error आणि percentage right if z is equal to f of x y if z is equal to f of x y if z is equal to f of x y then we have dz is equal to delta x by delta x dx plus delta x by delta y dy next here dx comma dy comma dz are known as actual errors in x, y and z respectively in x, y, z respectively and dx upon x comma dy upon y comma dz upon z represent relative error in the variable x, y, z respectively. And 100 dx upon x, comma 100 dy upon y, comma 100 dz upon z represent percentage error in the variable x, y, z respectively. The variable x, y, z respectively. Here we start example on errors and approximation, right? So the first example, consider in calculating the volume of a right circular cone. Errors of 2% and 1% are made in measuring the height and radius of base respectively. Find the error in the calculated volume. So we find solution. So we know that the diagram of right circular cone is like this. The axis, the line from the vertex is called the axis, and which is nothing but the height of right circular cone. This one is the radius r. We know that volume of right circular cone is V is equal to 1 by 3 pi r square. Right. So denote this one as a 1. Given that here we have to given percentage error in height and radius are 2% and 1%. You know that percentage error we denote by in height 100 dh by h is equal to the 2, and 100 in radius 100 dr by r is equal to the 1. So therefore volume, now here we have to calculate percentage error in the volume of right circular cone is equal to the question mark, right? So to find percentage error in volume, taking log on both sides in question. So the what we get, log v is equal to log of 1 by 3 pi r square h. By using the rule of logarithm, log v is equal to log of 1 by 3 pi into plus log of r square plus log h. That is log v is equal to log of 1 by 3 pi plus 2 log r plus log h. Differentiate this. So by differentiating, 1 upon v, dv is equal to, which is a constant derivative 0, plus 2 1 upon r dr plus 1 upon h. To find percentage error, multiply this equation by 100. So what we get, 100 dv by v is equal to 200 dr by r plus 100 dh by h. So therefore, by substituting the value is equal to 2. Here percentage error in radius is 1. Percentage error in height is 2. So we take the 2 plus 2, 4. So percentage, this implies that percentage A, percentage error in volume of right circular cone is 4. See the next example, which is a MCQ, right? The percentage error in the area of rectangle when an error of 1% is made in measuring its length and breadth is, and option we have to given: A 1%, B 2%, C 0%, and D 3%. So see here, the percentage error in the area of rectangle, that we have to calculate, right? So to find percentage error in area of rectangle, we know that the diagram of rectangle like this, right? So if we denote the breadth of the rectangle, which is by B, right, and the length which is by A. So what we have to given, the 1% error is made in the measuring its length and breadth. So if we denote the length by A and the breadth by B, so given that percentage error in the length, which is 100 dA by A, is equal to 1%, and percentage error in the breadth is 100 dB by B is equal to, which is also 1. We have to calculate area 100 dA by A is equal to the question mark. We all of know the formula to calculate the area of rectangle, which is area of rectangle, which is equal to A, which is equal to length into breadth, right? So the area is equal to A into, because the length we have to denote it by A and breadth we have to denote by B. So denote this one as a 1. To find the area, first we differentiate this one relation. So area, value of area is depend on these two parameter, length and breadth. In between these two parameter there is multiplication. So to, before the differentiating, partial differentiating, first we take log on both side. So taking log A is equal to log of A, which is equal to log A plus log. So differentiating, by differentiating, what we get, log A 1 upon A dA, 1 upon A dA, 1 upon B d. Here we have to find percentage error, so multiply both side by 100, 100 A upon A, 100 dA upon A plus 100 dP upon. So here substitute percentage error 1 plus 1, which is 2. So 100 dA upon A implies that percentage error in area of rectangle is to next example. Write down the resistance R of a circuit was found by using formula I is equal to E upon R. If there is an error of 0.1 ampere in reading I and 0.5 volts in E, find the corresponding possible percentage error in R when reading R I is equal to 50 and E is equal to 100 volts. Solution. So here we have to given the formula to calculate resistance, value of the resistance R. If we consider a simple electric circuit in which resistance is connected, see here. This one is the resistance R. Here's the current flow from the battery from positive to the negative direction, and the current which is denoted by I, and the battery which is connected, so electric power supply denoted by E. So here to calculate the resistance R, we have to given a formula I is equal to E upon R. So here some error in current while calculating current by using the ammeter, and also some error in calculating the volts which is given 0.5, right? We all of know we measuring the voltage by using the voltmeter. Whenever we measure the voltage by using the voltmeter, there is some error while measuring which is 0.5 volts, right? So due to the error in current and error in the power supply while measuring, so automatic the effect of that error in the value of the resistance R, and that error we have to calculate here by using the derivative, partial derivative. So see here how we calculate. First we write down here given things, given that. So here we have to given in the example 0.1 volt error in the reading I, right? We know that all of know if the error in X is denoted by dx. So here similarly the error in I will denote it by dr. So here which is 0.1. Similarly error in the voltage power supply which is a DE, and which is given 0.5 volts. This one is a 0.1 ampere and 0.5 volts. These are the error in current and the voltage respectively. So next
Here we have to calculate the percentage error in the resistance R. So the 100 dr upon R, you know that the percentage error in R is denoted by 100 dr upon R. This one we have to the calculate. When when the value of I is equal to the 15 ampere and the E is equal to the 100 volts. So for these particular values, we have to find the error in the resistance. So here formula is given to find the resistance R. So given that to calculate resistance R by using the formula R, so I is equal to E upon R. E upon R. So to simplify this one, first we take log on both sides. So taking log on both sides. So by taking log on both sides, log I is equal to log of E upon R. So log I is equal to, by using the rule of logarithm, this one is become log E minus log R. Right? So after taking the log and by using the rule of logarithm, here we have to separate out the function E and R separately. Here the between E and R there is a plus or minus sign. So here now to differentiate this one, by differentiating, so the we know that derivative of log I, which is 1 upon I di, is equal to the log E 1 upon E de minus 1 upon R di. So we need to find the percentage error, so multiply it by 100 di upon I, 100 de by E minus 100 dr by R. So here we have to find 100 dr upon R, percentage error in the resistance R. So we shift this percentage error in R to the left hand side and write down this current percentage error in the current in the right hand side. So that is therefore 100 dr upon R is equal to 100 de upon E minus 100 di upon I. So all these value we have to given 100, value of d we have to given 0.5 and A which is 100, here 100 volts we have to given minus 100, 0.1 divided by 50. So by calculating all these things, so the final solution we get 0 point minus 0.166 hundred dr upon R, which is a percentage error in R, right? So here error we get negative. So whatever the value of resistance we get by calculating uh, value of the resistance by using this formula, and there is some error in the value of I and E due to the some error in the machine. So the final error in the resistance. So the you know that for whenever we observe this formula, the value of resistance is depend on the value of E and R. If the some error in value of E and I is occur, so automatically there will be equal to the value of r, and which is minus 0.166. Next example, write down, find the possible percentage error in computing the parallel resistance R of three resistances R1, R2, R3 from the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If R1, R2, R3 are in error by 1.2%, are in error by 1.2% each. So solution, here in this example we have to find the error in the parallel resistance R of three resistance R1, R2 and R3, right? So suppose three resistance are connected in parallel. Here we draw the diagram. First one is R1, R2, R3. So by combining these resistance with these which are connected in the parallel R1, R2 and R3, so the parallel connected resistance R1, R2, R3. So if the error occur in the value of resistance R1, R2, R3, so the automatically the error will occur in the resistance R, because R is the resistance of this R1, R2 and R3. So solution, write down first given things, given that here see the statement R1, R2, R3 are in error by 1.2% each. So the error in here we have to given the error in terms of percentage. So we are here with value of error, we write in the percentage 100 dr1 by r1, 100 dr2 by r2 and 100 dr3 by r3 is equal to the 1.2%. So all the values are equal. So here we write 100 dr1 by r1 is equal to 100 dr1 by r2 is equal to 100 dr3 by r3 is equal to 1.2. Now, and we have to calculate here 100 percentage error in the R, 100 dr by r is equal to the question mark, right? So formula we given, formula to calculate R, which is a resistance of R, which is a resistance of three resistances which are parallelly connected. formula we have to given 1 upon r is equal to 1 upon r1 plus 1 upon r2 plus 1 upon r3. So from the formula, we observe that the value of r is dependent on the r1, r2, r3. If the error occur in r1, r2, r3, so definitely error in the value of r is occur. So these, so here we have to given the error in the r1, r2, r3, which is 1.2%, and the corresponding error we have to calculate in the value of r. So here there is no need to take log on both sides because r1 r in between r1 and r2 there is sign plus or minus, right? So whenever the multiplication in the parameter in between the parameter, that time we take log on both sides. Here r1 r2 r3 already separate out, so we directly differentiate this function. So by differentiating minus 1 upon r square square derivative 1 upon r square derivative minus 1 upon r square dr, 1 upon r1 square dr1 plus 1 upon r2 minus 1 upon r2 square dr2, so 1 upon r3 square dr3. So minus 1 upon r square and minus minus minus, so LHS RHS negative sign throughout cancel जर केले आपण, so what we get 1 upon r square dr is equal to 1 upon r1 square dr1 plus 1 upon r2 square dr2 plus 1 upon r3 square dr3. Here the value of error in given in terms of percentage, so multiplying 100 by both sides, so what we get 100 dr r square, 100 dr1 by r1 square plus 100 dr2 by r2 square plus 100 dr3 by r3 square. So to substitute the value of error, the value of error in the percentage error in r1, which is 100 dr1 by r1, so we arrange this term 100 dr1 by r1 square, so 100 dr1 by r1 into 1 upon r1, both are same, we just rearrange the things. Similarly 100 dr2 upon r2 1 upon r2 plus 100 dr3 by r3 to 1 upon r3. Now substituting the value percentage is term which is nothing but the percentage error in r1 and which is 1.2, 1 upon r1 plus 1.2 1 upon r2 plus 1.2 1 upon r3. So 1.2 is common, 1 upon r1 plus 1 upon r2 plus 1 upon r3, right, which is the value of 1 upon r1 plus 1 upon r2 plus 1 upon r3, which is 1 upon r. If we denote this one as 1 by 1, 1.2 1 upon r by 1. So here left hand side d 100 dr by r square, 1 r get cancelled, remaining 100 dr on r equal to 1.2, implies that percentage error in r is equal to is 1.2.